If a 1 by 1 square is halved every iteration, the area is quartered, as shown in the figure below. I guess if halved, I guess this side's halved and this side's halved, and the area is quartered. What is the area of the 7th square? Must be talking about the large one. Yeah, because this is a quarter area. This is going to be, we'll have to figure that out. And there was a total of the infinite series. Whew! I always like to write down to start the series. So we know that this area is 1 by 1, so that's going to be 1. So this area here is going to be 1 quarter. Then this area, well, this is a quarter, and it's a quarter of a quarter. Oh, that makes it a little easier. So it already tells me that it looks like a geometric series because it's going to be a quarter of a quarter. Right? That's what it's going to be. A 1/16. That guy is 1/16. There should be 16 little squares. Yeah, 4, 4, 4, 4. Yeah, 16. And then this guy will be a quarter of a quarter of a quarter. Okay, and I think the series goes on that way. So let's just check what these numbers are. 1 quarter, 1/16, and then this one's going to be, what's that? 4 times 16? 64th. 1/64th. Okay. Let's just check, because we always check if it's going to be a this will be a geometric series, but let's just check. So we can check if it's arithmetic. So it's an plus 1 minus a to the n. So, 1/64th minus 1/16th, and then also 1/16th minus 1/4. 1/64th minus 1/16 is going to be negative 0.046875, and then 16 inverse minus 4 inverse equals negative 0.1875. So they're not equal, not arithmetic. We knew that from the get-go. Not arithmetic. Let's try a geometric series. Woo! R is equal to a to the n plus 1 divided by a to the n. And now we're going to go, so it's going to be 1/64th divided by 1/16th. And that should equal 1/16th divided by 1/4. Okay, so that's going to be 64 inverse divided by 16 inverse equals, 1/4. That makes sense. And I bet you this one's going to be 1/4 as well. Divided by 4 inverse. Oops. Shoot. 16 inverse divided by 4 inverse equals, 1/4. Okay, so it is a geometric series. Geometric. Okay, so we know that the value for the nth value for a geometric series is going to be a to the n is equal to a to the 1 times r to the n minus 1. All right, so we know a1. a1 is going to be this guy, a1. And r, we determined 1/4. And n, we want the 7th one. We want the 7th value. So a to the 7 is going to be equal to a to the 1, which was 1/4, times ratio, which is 1/4, to the power of n minus 1, which would be 7 minus 1. So a to the 7 is going to be equal to 0.25 to the power of 6 times 0.25 equals. I'm going to put this in scientific notation because it is a pretty small number. 0.035 times 10 to the negative 1, 2, 3, 4, 5. 5. There it is. And now the infinite series, well, we know the sum, the geometric sum is equal to a1 times 1 minus r to the n all over 1 minus r. Okay, and we know that if this ratio is less than 1, yes, then that when we take the power to infinity, it will go to 0 for n approaching infinity. Okay, if r is less than 1. So we know that. So we know a1 and we know the ratio, so let's just plug these values in. So the sum to infinity will equal a1, which was 1/4, times 1 over 1 minus 1/4. Okay, so the sum, 1 minus 0.25 equals that, times 0.25 is going to be that. Let's put it in its fraction form, 3/16. Okay, so 3/16, or 0. No, there's something wrong here. There's something wrong here. Oh, because I multiplied it. That's why. There's something wrong. Because this number should be greater than 0.25. Because I know the area already starts off as 0.25. And I think it's because I multiplied by 3/4. So 1 minus 0.25 is equal to that. Inverse that times that by 0.25. And there's the answer. 1/3. That's a little better. I like that answer a lot better. So 1/3 or 0.3 repeating. It's approaching that. And that makes a little more sense because it has to be bigger than 0.25. And 0.25 plus 1/16, 0.25 plus 16 inverse plus 64 inverse equals, 0.32. And we're at 0.333333. So that's when you keep on adding them all up.